Electronic components. In this lesson, we will explore various electronic components, starting with a foundational introduction to microcontrollers, sensors, and actuators. We will explore key components such as resistors, capacitors, diodes, and inductors, understanding their functions and characteristics. We will also learn about input and output components, power sources, and the crucial role of integrated circuits, ICs. Furthermore, we will discuss power control mechanisms, connectors, and the essential tools and instruments used in electronics. Introduction. A microcontroller is a small computer on a single chip that can be used to control things like sensors, actuators, and lights. You almost use microcontroller every day. They are embedded in timers, thermostats, toys, remote controls, microwave ovens, and even some toothbrushes. They do one specific task. They have been programmed to sense and control activity using sensors and actuators. Sensors listen to the physical world. They convert energy that you give off when you press buttons, or wave your arms, or shout, into electrical signals. Buttons and knobs are sensors that you touch with your fingers, but there are many other kinds of sensors. Actuators take action in the physical world. They convert electrical energy back into physical energy, like light and heat and movement. Microcontrollers listen to sensors and talk to actuators. They decide what to do based on a program that you write. Microcontroller. Microcontroller. It is a tiny computer on a single VLSI integrated circuit containing a processor core, memory, and programmable input-output peripherals. The microcontroller often also includes program memory, as well as a small amount of RAM. These are used to perform one dedicated task. In this course, we are using following microcontroller programmable boards you can use to build interactive circuits. Microbit, based on ARM Cortex-M processor cores licensed by ARM Holdings. Arduino Uno R3 board, based on 8MEGA328, a single-chip microcontroller created by Atmel. The Microbit is a microcontroller board based on ARM Cortex-M processor cores licensed by ARM Holdings, and used for learning purposes mainly in the UK. It is a programmable board you can use to build interactive circuits. Microbit with breakout. It is microbit programmable board you can use to build interactive circuits, with a breakout board for easy connection to a breadboard. Arduino Uno R3 is a microcontroller board based on 8MEGA328, a single-chip microcontroller created by Atmel, designed for prototyping. It is programmable Arduino board you can use to build interactive circuits. Resistor. It restricts the flow of electricity in a circuit, reducing the voltage and current as a result. It converts some of the electrical energy into heat. If you put a resistor in series with a component like an LED, the resistor uses up some of the electrical energy and the LED receives less energy as a result. This allows you to supply components with only the amount of energy they need. You use a resistor in series with the LED to keep it from receiving too much current. The value or strength of the resistor is indicated by the colored bands on its body. For example, in a circuit without the resistor, an LED would be brighter for a few moments, but quickly burn out. The resistor helps reduce current in the circuit so that the LED does not exceed its maximum rated current. Their resistance value is often indicated by a series of colored bands. Here's how to read the color code. Bands 1 and 2. These bands represent the first two digits of the resistance value. For example, if the first band is red and the second band is green, the first two digits would be 25. Band 3. This band indicates the multiplier, or the number of zeros to add to the first two digits. For example, if the third band is orange, you would add 3 zeros to the first two digits. So, in our example, the resistance value would be 25,000 ohms. Band 4. This band represents the tolerance, or the percentage by which the actual resistance value may differ from the indicated value. For example, if the fourth band is gold, the tolerance is 5%. So, the actual resistance value could be anywhere between 23,750 ohms and 26,250 ohms. By using this color code chart, you can quickly and easily determine the resistance value of a resistor. Example: If the first band is yellow, representing 4, the second band is violet, representing 7, the third band is red, representing 10 squared or 100, and the fourth band is gold, representing 5% tolerance. The resistance value would be 4,700 ohms with a tolerance of 5%. Capacitor. The current in a circuit can change with power fluctuations which can damage the circuit. Capacitors are used to gradually reduce the amount of current being supplied to a component. Capacitor stores and releases electrical energy in a circuit at a steady rate. Polarized capacitor, a direction capacitor used to store and release electric energy in a circuit. Capacitance is a measure of a capacitor's ability to store electric charge. The formula for capacitance is C equals Q/V. It is defined as the ratio of charge, Q, to voltage, V. Capacitance is measured in farads, F. Typically, capacitors used in electronic circuits have a capacitance of around 1 microfarad, F. Diode. Diode allows electricity to flow in only one direction. A diode is a two-terminal electronic component that allows current to flow in only one direction. It is used in electronic circuits for a variety of purposes, including rectification, signal processing, and voltage regulations. One common example of a diode is the light-emitting diode, LED, which only allows current to flow in one direction. LEDs are used in a wide range of applications, including indicator lights, displays, and lighting. A diode circuit can be used to convert AC to DC and limit the amplitude of a signal. A protection diode is used to protect a circuit from reverse voltage generated by a spinning motor. Diodes are also used in signal processing, such as in clipping circuits. A clipping diode circuit can be used to limit the amplitude of a signal by removing any voltage above or below a certain level. This is useful in applications such as audio processing and power supplies where it is important to prevent overvoltage or undervoltage. Zener diode. Like a regular diode, but lets current flow in reverse if the Zener voltage is reached. One of the uses of diodes in electronic circuits is voltage regulation. Zener diodes are used in this application as they can be used in reverse bias to maintain a constant voltage across a load. Inductor. Inductor resists change in current flow. An inductor is an electrical component that stores energy in a magnetic field when electric current flows through it. It's often used in circuits to control the flow of electrical current. Inductors work based on the principle of electromagnetic induction, which states that a change in current through a conductor induces a magnetic field around the conductor. When the flow of electric current through an inductor is suddenly changed, the magnetic field surrounding the inductor collapses, inducing an electromotive force that resists the change in current. This property of inductors makes them useful for smoothing out changes in voltage or current in a circuit, or for filtering out unwanted signals. Inductors are commonly used in electronic devices such as power supplies, motors, and audio equipment. The value of an inductor is indicated by its inductance, which is measured in units of henries, H. The size of an inductor can range from a small component that fits on a circuit board to a large, heavy component used in power applications. Input components. Let's explore these input components. A push button or switch forms a connection in an electrical circuit when it is activated or closed. When the button is not activated, or it is open, it interrupts the flow of electricity, breaking the circuit. Potentiometer is a type of resistor whose resistance changes at the turn of a knob. It is also known as a pot, and it is a variable resistor. It consists of a resistive element, a wiper, and two terminals. The wiper can be moved along the resistive element to adjust the resistance between the terminals. Potentiometers are commonly used to control the volume or tone of an electronic device, such as a radio or guitar amplifier. They can also be used as a position sensor or as a variable voltage divider. Slide switch. A switch with two position, open or closed. Photoresistor. A sensor whose resistance changes based on the amount of light it senses. Photodiode converts light to electric current. Ambient light sensor, phototransistor. Uses ambient light to control the base of an internal NPN transistor. Flex sensor, a sensor whose resistance changes as it bends. Force sensor, a sensor whose resistance changes based on the amount of force applied. IR remote control emits IR signals. IR sensor detects IR, infrared signals emitted by devices like remote controls. Ultrasonic distance sensor uses sound waves to determine how far away an object is from it. Passive infrared motion sensor is used to sense motion in front of it. Soil moisture sensor, a sensor whose signal voltage changes as it gets wet. A tilt sensor is a device that detects the orientation or angle of inclination of an object relative to gravity. It works by measuring the force of gravity acting on the device and converting that into an electrical signal. The electrical signal can then be used to control other devices, such as lights, motors, or alarms. Tilt sensors come in different forms, including mechanical switches, mercury switches, and solid-state sensors. Some tilt sensors use a ball inside a tube to detect changes in orientation, while others use a pendulum or liquid inside a container. The output of a tilt sensor can be an analog signal, which varies in proportion to the angle of tilt, or a digital signal, which indicates whether the device is tilted past a certain threshold. SW200D, tilt-sensitive trigger switch. Tilt sensor 4-pin, a 4-pin tilt-sensitive trigger switch found in Arduino kits. Tilt sensors are used in a variety of applications, including gaming devices, security systems, and robotics. They can also be used to control lights in a room, trigger an alarm when a device is moved, or change the direction of a motor when a device is tilted. A temperature sensor is a device that measures the temperature of an object or environment and converts it into an electrical signal that can be read by a computer or other electronic device. The most common type of temperature sensor is a thermistor, which is a resistor that changes its resistance based on temperature. Other types of temperature sensors include thermocouples, RTDs, resistance temperature detectors, and infrared sensors. Temperature sensors are used in a wide range of applications, including HVAC, heating, ventilation, and air conditioning systems, industrial process control, automotive systems, and consumer electronics. They can also be used to monitor the temperature of medical equipment, food storage, and laboratory experiments. The output of a temperature sensor can be in the form of an analog voltage or a digital signal that can be read by a microcontroller or computer. The accuracy of a temperature sensor depends on its type and the range of temperatures it can measure. Some temperature sensors are designed to measure very high or very low temperatures, while others are designed for use in harsh or corrosive environments. TMP36, a sensor that outputs different voltages based on the ambient temperature. A Windson gas sensor used to detect gas leaks like carbon monoxide, alcohol, or methane. Keypad 4x4, a 16-button keypad with digits 0 to 9, letter AD, and the asterisk and hashtag symbols. Dip switch DPSD, a single dip switch. Dip switch DPSD-X4 contains 4 individual switches. Dip switch DPSD-X6 contains 6 individual switches. Output components. Now let's explore these output components. LED is a light-emitting diode that lights up when electricity passes through it in the correct direction. LED RGB, a type of LED that combines red, blue, and green to produce any color. Light bulb, a 12V/3W incandescent light bulb. NeoPixel, a single RGB LED that can be controlled using a microcontroller. NeoPixel Jewel, a set of 7 NeoPixels that can be individually controlled using a microcontroller. NeoPixel Ring, a ring of December 16th, 24 NeoPixels that can be individually controlled using a microcontroller. NeoPixel Strip, a flexible strip of RGB LEDs that can be controlled using a microcontroller. Vibration motor is a motor that vibrates when powered. A DC motor is a type of electric motor that converts electrical energy into mechanical energy by using the principles of induction. It consists of a tightly wound copper coil that creates a magnetic field when supplied with current. This magnetic field causes the shaft of the motor to spin. A DC motor with an encoder is a type of DC motor that includes a device for measuring the rotational position and speed of the shaft. The encoder provides an electrical signal that can be used to control the motor's position or speed. Actuators offers 3 to 12V or 6 to 12V planetary gear motors with encoders, which are heavy-duty and suitable for a range of applications. Microservo is a motor whose position can be controlled using a microcontroller. Hobby gear motor is a geared motor that is often used to drive robot wheels. Piezo is a type of buzzer that makes noise at different frequencies. Display. 7-segment display. A single 7-segment LED for displaying a number of letters. LCD 16 by 2. A liquid crystal display capable of displaying 2 lines of 16 characters. LCD 16 by 2. I2C, a liquid crystal display capable of displaying 2 lines of 16 characters. 7-segment clock display. A 4-digit 7-segment LED display controlled by I2C. Power. 9V battery. A common battery for higher power applications like motors. 1.5V battery. Standard AA or AAA batteries with each battery providing 1.5V. Coin cell 3V battery. A small battery great for low power applications like lighting up LEDs. Solar cell. A device that converts light into electrical energy. Integrated circuits. Older devices use glass or metal vacuum tubes to control the flow of electricity. With these components, a low power voltage could be used to change another, and that's why they are useful in amplifiers and switches. By the late 1960s and early 1970s, the transistor and semiconductor began replacing vacuum tubes. Transistors can be made much smaller than vacuum tubes, and they can work using less energy. At about the same time, integrated circuits that have a large numbers of very small transistors placed on very thin slices of silicon, became commonly used. Integrated circuits made it possible to reduce the number of parts needed to make electronic products and made the products much cheaper in general. Some common types of ICs include 741 operation amplifier, comparator, optocoupler. A timer is an electronic component that can be used to measure time intervals and trigger events. A general-purpose single bipolar timer is a type of timer that uses a single bipolar transistor to control its timing. A dual timer is a timer that combines 2 555 timers in one package, allowing for 2 separate timing circuits to be used in a single device. Timers are commonly used in a wide range of applications, including alarm clocks, washing machines, automotive systems, and industrial control systems. Single timer, general-purpose single bipolar timer. Dual timer, combines 2 555 timers in one package. 741 operation amplifier, is used to amplify or filter analog signals. The 741 operational amplifier, op-amp, is a type of linear integrated circuit that is widely used in a variety of applications such as amplification, filtering, and signal conversion. It is a direct-coupled high-gain amplifier that can be used in either single-ended or differential input configurations. The op-amp has high input impedance and low output impedance, making it well-suited for use as a voltage amplifier. The 741 op-amp is known for its versatility, ease of use, and stability, making it a popular choice for many electronic applications. A comparator is an electronic component that compares 2 input voltages and outputs a digital signal indicating which voltage is greater. The output signal is typically a high voltage for one input and a low voltage for the other. The LM339 and LM393 are 2 examples of comparators. The LM339 is a quad comparator, meaning it has 4 independent comparators in one package, while the LM393 is a dual comparator, meaning it has 2 independent comparators. Both are powered by a single supply and can be used to compare voltage levels in various applications. Quad comparator. LM339 consists of 4 voltage comparators, powered by a single supply. Dual comparator. LM393 consists of 2 independent voltage comparators. Optocoupler transfers signals between 2 circuits using light. An optocoupler, also known as an optoisolator, is an electronic component that isolates 2 circuits electrically while allowing them to communicate via light. It consists of an LED and a phototransistor, and it is used to transfer signals from one circuit to another without allowing any electrical connection between the two. Optocouplers are commonly used in applications where electrical isolation is needed, such as in power supplies, motor control, and data communication systems. They provide protection against electrical noise, overvoltage, and ground loops, and also ensure safe and reliable signal transfer between different parts of a system. Power control. Let's now explore the transistors, relays, regulators, motor controllers, and motor drivers. Transistors are components that let you control high current and high voltage signals using the low current output of the Arduino. You can think of transistors as digital switches. When you provide voltage to one of the pins, called the gate, it closes the circuit between the other two pins, called the source and drain. NPN transistor, BJT. A component used to amplify or switch electronic signals. Commonly used with motors. PNP transistor, BJT. A component used to amplify or switch electronic signals. Commonly used with motors. Tip 120. NPN Darlington transistor used for switching on high-power electronics like motors. Small signal voltage control transistors. Small signal transistors are transistors that are used in amplifiers, switches, and other applications where the input signal is small. They're designed to operate with low input signals and provide a high gain. Small signal NMOS transistor. Small signal PMOS transistor. Large signal voltage controlled transistors. Large signal transistors, on the other hand, are used in applications where the input signals are larger, such as power amplifiers, high-power switching, and other high-current applications. They're designed to handle larger input signals and are capable of delivering high-power outputs. NMOS transistor, MOSFET. PMOS transistor, MOSFET. A relay is an electrically operated switch that allows a low-power signal to control a high-power circuit. It consists of a coil, armature, metal spring, and contacts, which work together to enable the flow of current in the high-power circuit. Relays are commonly used in various applications, such as controlling motors, lighting, and safety systems, and offer advantages such as high electrical isolation and high switching capacity. Relay SPDT. A 5V SPDT power relay for switching between two circuits. Relay DPDT. Miniature 5V DPDT power relay. Regulator controls voltage/current in a circuit. Maintains constant output in response to input changes. Types: voltage, current, switching regulators. Ensures stable performance in a circuit. Widely used in power supplies and control systems. 5V regulator, LM7805. Used to provide a fixed 5V output voltage. 3.3V regulator, LD1117V33. Used to provide a fixed 3.3V output voltage. Pololu simple motor controller is used for bidirectional control of single DC motor. H-bridge motor driver. Capable of running two DC motors or one bipolar or unipolar stepper motor. Connectors. For example, here you can view a 8-pin header with 0.1 foot header spacing and type a male standard USB connector. Instruments. Now let's briefly discuss few more electronics instruments. An ohm meter or multimeter is a measuring instrument that can measure multiple electrical properties. A typical multimeter can measure voltage, resistance, and current, in which case it is also known as a voltomilliammeter (VOM), as the unit is equipped with voltmeter, ammeter, and ohm meter functionality. Some feature the measurement of additional properties, such as temperature and capacitance. Here you can view electronic test equipment for supplying power to your circuit. Function generator is an electronic test equipment that generates various voltage waveforms. Oscilloscope is an electronic test equipment to measure output signals.